Hey there, welcome to another college algebra video. This is the second half of section 8.1. We've recorded a video part 1, this is part 2 because 8.1 has a lot of stuff in it. And so in this video we're going to identify systems that do not have a single ordered pair solution. They may have lots of solutions or they may have none. And we'll see what that looks like, and then we're going to show you how to use systems of equations to solve word problems. Okay, so just as a little bit of a refresher, there are really three things that can happen when you have a system of equations, and the first video deals exclusively with this scenario, and this is the most likely one. Okay, this happens the most often, and that's when you have two linear equations. They're each a straight line and they intersect at exactly one point, so you get one answer. You get one ordered pair as your answer, x comma y. But there are two other possible options. You have two lines, but they happen to be parallel. If they're parallel, they don't cross each other, and if they don't share a point in common, then there's no solution. So that's the first other possibility, is that you have two parallel lines, so you have no solution. The second possibility is that you have two equations, but it's the same line, right? If I have y equals 2x plus 1, and then I multiply everything by 3, 3y equals 6x plus 3, well, they're the same line, because if I multiply both sides by 3, they stay equivalent, right? And so these two lines would be the same, and if you want to graph them, then you would have basically all the points on this line are also on that line, and so you have infinitely many solutions. So those are the different possibilities. Let's take a look at how this plays out. We're going to use addition to solve this system. Notice that this has a negative 10x and this has a 5x, and so if we multiply by positive 2 here, everything by positive 2, 2 times 5 is 10x, 2 times negative 2 is negative 4y, and then 2 times 4 is 8. And we just bring this one over the way that it is, negative 10x plus 4y equals 7. Now, we were getting rid of the x's, 10x minus 10x is 0x, but look what happened to the y's, negative 4y and positive 4y is also 0. 8 plus 7 is 15. So you get the number 0 equals 15. Well, that never happens. That's impossible, right? It's impossible for 0 to equal 15. And so what does that mean? That means we have no solution. And so you write no solution, or you can write the empty set, a 0 with a slash through it. Okay, I'll take either one of those. And so what's happening here, what's happening is when you graph this line, okay, if I solve this for y, I get y equals 5 halves x minus 2, which is this line right here. But if I solve this guy, right, I get y equals 5 halves x plus 7/4. Right, which is that line right there. So I get two parallel lines, they have the same slope, and so they don't intersect. Right? Now, what about a system where you're using substitution? What does that look like? Well, let's do substitution here. This is already solved for x, and so we get 5 times x minus 20y equals negative 40. This 4y minus 8 goes in for x. Distribute the 5, you get 20y minus 40 minus 20y equals minus 40. So 20y minus 20y is 0y, but this time we get negative 40 equals 40, and that's not impossible, that's true. In fact, that's always true. So what does that mean? What that means is that these two lines share the same points in common, which means they're the same line. All right, and so we have infinitely many solutions. But here's the thing. You can't just say infinitely many solutions, and you can't just say all real numbers, because it's not all real numbers, right? There's lots of points that are not on this line. So you have to describe what those infinitely many solutions look like. All right, how do I do that? This is set builder notation, and what this says all the ordered pairs x, y, such that, the bar is read such that this equation is satisfied. Or this equation is satisfied. It doesn't matter which one, you can use either one. But you basically write out all the points such that your equation is true. That's how you write that. And that's how you read that. All the points that lie on this line. All the points that lie on this line. Because they're the same line. Okay? And that's the way you need to write your answer in set builder notation. I know it's a little bit more complex than most of the other stuff, but that's what you've got to be able to do. Okay? So pause the video at this point. You can use either method to solve the system. You can use substitution or addition. See what happens. You're going to get something, one of these two options. You're going to get either parallel lines or you're going to get the same line. Make sure you express your answer properly, and we'll go over it in a minute. Okay, so depending on how you decided to do this, I would solve this bottom one for x. Negative 2x equals negative 4y plus 8. Divide everything by negative 2 because it avoids fractions, and I get x equals 2y minus 4. And we're going to do substitution. So 3 times x is 2y minus 4, minus 6y equals 12. Distribute. 6y minus 12 minus 6y equals 12. So we get 6y and 6y is 0. You get negative 12 equals 12. Close, but not the same, right? And since that's not the same, that means I have no solution. All right, hopefully that went pretty well. So the only other thing we have to talk about for linear equations is word problems. All right, so here's an example of what we're talking about. They took a field trip to the High Museum, middle school students with adults and students. Tickets were $8 an adult, $3 per student, and there were 120 people that went total. The entire cost was $430. So how many students went on the field trip? How many adults went on the field trip? So you have two things you don't know. How many adults and how many students. If you don't know them, then you need to call them variables. So x is how many students. Well, I'll do adults first, I guess. How many adults? Doesn't matter, right? Y is how many students, or number of students, probably a better way to put it, but either way you're good. And now I need two equations. If I have two unknowns, I need two equations. Well, what do I know? I know cost and I know numbers. So I should get an equation for each of those. The numbers is pretty easy. How many people went? How many people went? 120. So x plus y has to be 120. But what about the cost? If tickets were $8 per adult, how much did they pay for the adult tickets? 8 times x, right? The number of adults times $8. And 3 times y is the number of students times $3, and that's supposed to be a total of 430. So here is your system of equations. Okay, now for practice, I'm going to suggest that you pause the video at this point and go ahead and solve it. The setup is the hard part, quote unquote, but this is really not that hard. You pick these two variables, and then you have the two obvious relationships, cost and numbers of people. But you guys go ahead and solve this, pause the video and solve it, and then we'll go and finish it out. Okay, so if I solve this using addition, multiply by negative 3 to get rid of the y's, I get 8x plus 3y equals 430. I get negative 3x minus 3y equals negative 360. Multiply the negative all the way through. And so we add these together and get 5x, 0y, and this equals 70. So divide both sides by 5. X equals 14. That's not the complete answer. You got to take that and plug that back in. Plug back in up here. You get 14 plus y equals 120. Subtract 14 from both sides. Right, you get y equals 106. So how do we answer this question? We answer this question with a sentence or with words at least. So there were 14 adults and 106 students on the field trip. Okay? And that's going to be the way that I expect you to do these kind of problems. Okay, I need to see your work when you're doing these problems in my math lab, whether it be a quiz or whatever. I need to see the work involved. I need to see 2 equations. I need to see your variables labeled. X is this, Y is that. I need to see the system. Okay, in order to get credit, you got to show me all that stuff. Okay, so lots of practice on these, and we'll see you later. Thanks.